And hello, everybody. You're very welcome to a new On Location episode. This is Sean Martin, and Marco and I, even though he's not here, we're on our way to InfoSecurity London and InfoSecurity Europe in London, I should say. And we're excited to hear all kinds of things, obviously cyber related to business, policy and governance, and in public and private sector, privacy. I'm sure we'll touch on there as well. All in support of enabling secure business, protecting customers along the way, and hopefully, if we do our job right, a safer society that gets along and doesn't attack each other. Exactly. So, so as part of our coverage, we're chatting with a few keynote speakers, and I'm thrilled to have Professor John Goodacre on. How are you, John?
Very good, thank you, Sean.
That's great. You're a busy man, researching stuff, involved in programs, attending and speaking at conferences. Give us a little background on who Professor Goodacre is and what you're up to these days.
Yeah, so I've had a varied career in telecoms. I spent 6 years at Microsoft in Redmond. I spent 17 years at ARM, and it was really on the back end of that ARM stuff that I started obviously being a professor doing supercomputers, which we're not going to talk about today. But the other thing that I started was worrying about our cyber resilience and integrity of our systems, and whether or not there's more we can do than just patch and chase after bugs before the attackers find their way in and take over our systems. So that's really what I've been doing for the last 5 years, and I've been doing that as a director of a UK government program. So I'm sure we'll get into more details of that as we talk this evening.
But John, I'm afraid that when we say we're going to take care of the chasing vulnerabilities with patches, we're gonna take away some job security from folks, I think.
Oh, I don't think so. I don't think there'll ever be a silver bullet. I was a colleague, myself and a colleague or an ex-colleague, I suppose. I suppose we're still trying to attack this problem together from ARM. We're giving governmental select committee evidence just last week, in fact, and he described it as an ongoing battle, an arms race against the attackers. So, I think that the big challenge really that we identified was that that things haven't really changed for quite a long time, and it's just getting unsustainable for a lot of businesses and being able to maintain this. This is then obviously driving a skill shortage of people that can actually run around. So what we looked at was actually, is there a way of actually protecting people by design in the technology? And obviously in the UK government's national strategy, we looked at bringing technology into the funding scheme, and it was that scheme that actually started this digital security by design program back in 2019. And what we wanted to do was basically say, can we actually fix the foundation of technology so that the technology itself can protect us, as opposed to leaving it to the billions of users that use our digital systems to actually try to manage and de-risk themselves. So the program basically kicked off then. It was at the time it was a £70 million investment by the UK government, but really it was to overcome a market failure. And because of that, we were basically the conveners with big business, and we had Microsoft, Google, and others all basically promising, at the time, over £100 million of co-investment to say, can we fix the foundations of our digital infrastructures so that, basically we can reduce that load. And that's what the program started to look at. And obviously it was one that looked across the research part. It looked at the technology itself. It looked at what the impact to businesses were. And, pretty unanimously, as people started looking at it, we can take out, Microsoft actually did a great paper where they said, basically, if we look back in time at our last 5 years of patches that we've had to give out, this would have stopped 70% of them having to exist. So from that, you can start seeing that there's an ongoing cyber reduction. No silver bullet, it's not 100% or anything silly like that. But if you can take out 70% of the noise of this. And since that sort of started, we've come up with some good language. It's starting to go global and things like that. So happy to delve into any of those areas you think it will be of interest. And obviously in my talk at the show, I'll be going into more details of how we've changed the language into by design, by default, cybersecurity, a pyramid. If we can fix it, with only a few hundred people looking at it, but in effect billions, it's, how do you get a billion people not to click on a link? Quite hard. How can we make it if a billion people click on the link, nothing happens? So that's been our approach in the program, basically, to try to fix things by design in the products themselves at the lowest level of the foundational technology in the CPU. If we start getting techie, if that's interesting.
Yeah, actually, I wanted to start there because I know you have a lot of history in the hardware, right? With ARM, certainly.
Yeah.
So that's the base, and then of course you have the network, which is more hardware and networking protocols, and then you have the applications on top of that,
software, and
up to the users. And so, how far and wide does this program cover? Are you working with hardware manufacturers, the software developers, the telcos?
One of the things I'll be probably using at the presentation is something I call the cyber pyramid, and it's a reverse pyramid where we're balanced on basically
that point hurts. It's sitting under.
That point really hurts, and that point of pain has actually been there for about 50 years. So, computers back in the 40s and 50s, they were very expensive to build. The transistors, every transistor was really, really important. And obviously the cyber threat wasn't really there when we started. But by the 70s, even the American government was starting to publish things saying, we should probably change the way we run software on these chips, because any mistake in the software, there's a class of problem called memory safety issues. A lot of people may have heard that coming out of the US government in quite loud voice recently, that this huge amount of general problems that people accidentally or as we've seen, supply chain attacks actually start making problems in software that there's no defense in the hardware against basically starting executing code, taking your data, putting you to ransom and things like that. So what we did in the hardware, or should I say, there was a University of Cambridge here in the UK have been looking for about 10 years. What can we do to change the way hardware runs software so that these memory safety issues are not exploitable, but also how do we then put software, both the code and all the data, in very fine-grained boxes? It's called compartmentalization, but the idea that we can protect or a developer can protect themselves against either explicit or accidental vulnerabilities in third-party code. And can we do this in the way people write software today, which is a bit of that software, a bit of that software, let's glue it together and ship a product? Nobody's going to rewrite the trillions of lines of code that they currently integrate in a different language that still isn't, making a significant difference to the risk of that system having issues in the future. So, what we've ended up with, and what the program has been able to show in the last 5 years, is that we stop those vulnerabilities. We've shown that the developers can have a significant productivity gain, in the sense that things that may be slightly wrong in their design or their implementation are caught very quickly. And then obviously in the deployment of it, the fact that those customers don't have to run around patching quite as often. And, things that today are very serious day zero bugs, let's look at the WebP ones recently, where somebody could just send an image to you by whatever means and take over your entire handset or computer. Not a good environment to be in, whereas the bug may have still existed, but run it on this kind of hardware, it would have been nothing. Worst case, a crash. Best case, they say, sorry, invalid image. It's that kind of change that we're looking at bringing through to the platform. And obviously in my talk, I'll be covering more, how does it do it? How do we get that into the supply chain? How customers access the technology? Where's it actually coming from? And that, going back to the pyramid, there's only really three architectures: the ARM architecture, the RISC-V architecture, and the x86 architecture. Fix it in those three, and you've actually got the billions and billions of devices across the world in all sectors, all markets, having this level of upgrade, if you like, to the way that hardware runs software.
Interesting. So I'm trying to picture this. Is I don't want to demean it, but is it a shim between the hardware and the applications, or what's that look like?
Well, there is a shim. It's called an instruction set architecture. So basically, hardware has a contract with software. It says, if you show me this instruction to add two numbers, then I'll add two numbers together for you. Okay, so it's at that fundamental level of hardware and software. If it says, if this value is greater than 1, then jump, else don't jump. It's that instruction within the computer that's changing. And at the moment, the computer has a view that if I've got an integer value, a number, then I can use that to point at memory and read the memory. Okay, or if that's on the stack, I've got a string on the stack, a sequence of characters. Oh, let's make it a bit longer. Oh, those characters are now instructions. Please, when you return off the stack, start running my code. So those kind of things are basically inherent in the mistakes of software. And I don't think anybody I found anybody that will say there's never a bug in software. And I found, some fairly high integrity.
There's a reason the OWASP top 10 has lasted for so many years, right?
And
basically the same list.
And about 5 or 6 of those top 10 classes of errors are all of these memory problems, using something that was freed, writing off the end of a buffer, OpenSSL, Heartbleed, reading off the end of a buffer so I can go and get hold of your keys and your password. Those are all the kind of things that if you don't just use an integer, but you use something called a capability that the hardware says, I can only read what I've been given permission to read or write or execute at a very fine-grained, high-performance way, then hey presto, the world's a much better and safer place to work, and your systems are more resilient, and the integrity of your data and operations are higher. So it's not something that you effectively buy and apply. It's not a tool. It's not a monitoring tool. It's not a piece of software that you run on your system. It's changing the way computers historically have run code to run it in a way that protects you against exploitation and allows you to constrain your image viewer. It's a good example because it's been quite popular recently as a way into a system. Put it in a box and it can only write to its image decode buffer. It can't go reading and writing the boot vector of your code and taking your money out of your bank. So obviously for C&I and things it's a different case, but there's all good things. Yeah.
So many questions in my mind.
Go for it.
Let's see. So let's go here first. So actually, I spoke with Bob Lord. He's with CISA, part of DHS, and we talked a bit about secure by design software. Then they have basically an effort underway to tackle the same issue around memory issues in applications. My question is, are you working with DHS, CISA, or other government entities to kind of make this broader?
I've been over to the States and the agencies quite a few times over the years, sort of sharing this view that, we can no longer just do cybersecurity where the user of a system is responsible and liable for its operation. We have to go to two lower levels. The first lower level is by default, where those manufacturers are taking more care about not shipping such a large attack surface at us, don't turn on features that shouldn't be turned on, and don't ship as default passwords. We've actually recently in the UK, law made that illegal to ship as a POS, a consumer product with default passwords now. And then the layer beneath that, where the products and the components actually by design in their implementation can help protect us. Now, I think the language of, user memory safe language is great. Obviously, that doesn't very well address the historical legacy of everything. And what we're saying is, great story. Here's a roadmap that can actually bring legacy under that protection as well. So, and actually, for even if you do start writing Rust and other memory safe languages, they have an unsafe component to them. run that Rust on these platforms, you now have that unsafe component also protected from memory safety. And this idea that even if you're writing in memory safe language or a legacy language, you can start constraining and bringing in policies between libraries in your code, between functions and data structures that, again, can operate at very high performance. We're seeing some of the, I'm sure our listeners have heard some of the vulnerabilities in our cloud stack recently and our virtualization things, and the idea that you can now put that same software into these boxes and basically run it, orders of magnitude faster. It's all sort of a positive sort of way. Let's design a computer that runs code differently. It can still run the existing code. The cost of change and the cost of adoption is minimal. We've shown in this, there's actually more lines of code running on this platform than there have ever been lines of code in the open source for Rust, for example. And obviously the rate of authorship of legacy language non-safe code is faster than the rate that they're writing it back in new languages. So this is a divergent problem, not a convergent problem. So what can we do about it? And obviously my talk will be covering what's happening and what needs to happen in the future and what people need to know about it to be able to start pulling this through the supply chain and creating roadmaps in which, the businesses themselves can obviously start benefiting from the reduction of that, the threat against them. It's a de-risking strategy for cybersecurity. Let's fix some of those root problems, not just band-aid it with patches.
Yep, or policy. and audits that take up a bunch of time as well.
Yeah, clearly, if we can have some language of, it's in some senses, I think it's almost becoming socially unacceptable, isn't it, to be shipping products that can still be attacked in ways that we know how to attack them. And even school kids are taught at school, what a memory, buffer overflow is, and it doesn't take them long to realize that they can just send a few extra characters and start executing random code, that kind of thing. We've just got to get rid of that as soon as we can. And it's now really a business adoption and commercial and policy kind of discussion on how do we protect ourselves, and it's a global problem. How do all the governments get together and basically say, hey, suppliers, start doing this by design and by default. Otherwise, the cybersecurity and the billions of peoples and the businesses and the digital economy benefits are all at threat, aren't they, basically? And it's, I think we went from, was it 18,000 reported vulnerabilities a year and a bit ago to 30,000 this year? People are doing a lot to reduce it, but the amount of digital code that's been written and the ferocity of people attacking systems, the number of vulnerabilities is going up exponentially if you look at the charts.
No, I don't necessarily want to head down this path, but the AI writing code is just going to amplify all those bugs, right?
I think there's a few things around AI. Obviously, AI can attack, AI can defend and tell you what's going on a lot faster than a lot of SOCs can run around and see it. But then the other part of AI is it's also an area that could be under attack itself. So if you've got an AI that's doing some recognition or is something wrong, it's running on this huge stack of legacy code, operating systems, and interpreters. It's just a data structure in memory that can be tweaked by a buffer overflow in the decoder of the network stack. It's just as vulnerable as everybody else. It's not, it's not the answer to everything. It's clearly going to, escalate the rate at which vulnerabilities can be exploited or protected or seen. But itself, it itself is going to be vulnerable. But also, if you start looking at the inference models between I own the model and that's my value, and I want to sell it to somebody so they can spot smiley cats, how do you protect your IP? Because clearly you're under a threat that somebody can take your model and your business is gone. So, this is where the containerization can help for AI as well. Separate the model from the interpret from the rest of the system, and you're protecting your IP as well. So there's lots of stories, and it's just a case of prioritizing which ones are the key ones that are going to cause it to be ubiquitous across the whole of the sector, all the sectors.
Yeah, and I think one of the things that you shared prior to recording the this mindset that we have to establish, and that starts with some awareness, with some training and education. Can you touch on that a bit for me?
Yeah. So if you know, I said earlier that these problems have been in the computer architectures for 50 years. Okay, obviously not all of that time it was under threat and under attack, but in essence, how many people are as old as me that can remember that there was actually different types of computers back in the 60s and early 70s? Yeah, we had stack-based Lisp machines that didn't run with this idea that a single number can read all your memory. But that, you know, by the mid 70s, early 80s, that was the ubiquitous model, that you have an integer number and it can read all your memory. Now, obviously, there's been things stuck on the side since, and trying to constrain how much it can read, but they're very expensive to implement. A lot of those partitions. So, how we take that forwards, it's up for discussion. But please, I don't think I fully answered your question there. So go back and ask me again.
Well, I'm just wondering. So new stuff, I think we need to create with secure by design, secure by default in mind, right? So yes, we have the legacy. We need to come to a certain point where we're protecting a lot of that, and then new stuff moving forward. So how do we get to a point where we can scale secure by design, secure by default?
Yes, so
make a difference there.
So obviously the by design, for me, it's just geeking out for a moment. It's all about abstractions and the leakage of data across abstractions. Okay, so the whole of our digital economy is built on abstractions, whether or not it's the way a transistor works in analog and electricity, so you can side channel attack through heat, or whether or not it's the hardware software division, or whether or not it's the operating system application boundary, or whether or not it's the driver. It's all the abstractions that are leaking. So, in essence, it's bringing that into the education of the people who are working either to provide the abstraction, that's where the by design bit comes, or the people that are using abstractions, and that's where the by default comes. So if I'm a designer of a product that's integrating and shipping a whole load of abstractions and a whole load of functionality, I better understand the by default, I need to design this to be more secure. And if I'm shipping that abstraction, I'm shipping the transistor, the hardware chip, the network stack, the protocol interface, I better not do things that aren't by design working. So, obviously I've spoken about this memory safety by design, but there's other ones. Where do I hold the magic key, the keys of the system? Okay, have I designed it in a way that it just sits in that flat memory space that allows people to read it? Well, 80 or 90% of the chips, that's true today, but there's a growing number of them that are putting in roots of trust, and they're putting in protected stores and things like that. So it's an educational thing that the people using it, those developers at the top, actually knowing that says, well, is what I'm buying got by design capabilities in it, so that it makes my life and protects me against any mistakes I might make in my level of the supply chain. Obviously, the big recent news on the supply chain was that one that was going into the SSL stack for Linux recently. And again, you could say, well, I want to use a library. I might not know its full providence. I better be able to put it in a box, protect myself by design, that those libraries I'm using, there's no way that they can get out and start doing things that they weren't expected to do. So, we're starting to see that in the UK here. We've got something called SciBoc. It's a long list of educational areas of interest, and we're feeding into that becomes basically what the academia or the teaching community then spreads out through their teaching. So, hopefully we'll get this concept. But I think just getting the language and starting to see examples of this coming through the supply chain will obviously hopefully pique the interest of, component developers, the hardware developers, the system software, getting them into the application spaces. And then at the top, we're seeing it with governments reporting like CISA, as you say, putting out, go and do this stuff. What's your roadmap to memory safety, guys? What's your roadmap to by default? In the UK here, we've got our PSTI bill. You better make sure you know how to upgrade and support your devices and not put default passwords on them. So, I think the language is getting there. I think there's a global alignment coming in that. Yes, there's a focus on what I can do today in writing in memory safe languages, but like I say, there's an unsafe bit in that as well. It doesn't, just because I wrote it in Rust doesn't mean it's memory safe. It's an interesting one. Just because I run it on a memory safe chip, it doesn't mean it's memory safe either. Well, some of the microcontroller stuff we're doing, it is, but it's an educational step, and obviously the reason I'm offering to share my talk next week is to make sure that more people know about this hierarchy, these areas of responsibility, rather than just saying cybersecurity.
Yeah.
Have you packed? Do you know what your SOC is? Do you know what your risk mitigation is? Do you know what your recovery mechanism is? Yeah. Yes, it's very important. You need to know all those, because you've got attacks that aren't at technology level. But if we can do something about the technology level and the threats that they're bringing, then you can start worrying about the real ones, which is, am I running the right functionality at the right time for the right people?
Yep. Yeah. Then we're going to focus on the logic part of it.
Yeah. Yeah. It was funny. There was a big workshop that was looking at the growth and the skills requirement for cybersecurity. So they were saying we need more people that understand how to protect their systems and how to run monitoring. I was going, look, let me paint that as a slightly different picture for you. Ultimate success. 90% of your population in employment is running around patching your systems, knowing how to run it. Is that the economic growth and prosperity you want? And they went, oh, yeah, no. Okay. So what you really want is to make their lives easier so they can focus, sustainably at what's required, which is, offering great service and doing it in a resilient and high integrity way. Yeah.
Yep. It's funny. I've had this conversation a few times, and it I don't know, I'm a nerd this way. It rolls around in my head almost 24/7 that I believe security has knowledge and data and experience, if applied at a business level. We spend tons of money on marketing, right, to fine tune the qualified lead to deal, right? If we did that math, looking at how do we tune business operations, business processes, so that they stay up all the time and they can't be compromised.
Security is a real interesting one to understand what the economical ROI, return on investment for security is, because there's one of our demonstrators that's basically converted the entire stack right the way from the boot up to the graphical browser it's in something called Cherry BSD. It's a BSD Linux like environment, and they tried to demo it, and someone said, yeah, it's a computer. What's the value of that above that one? And it's actually very hard to sort of say, well, it's not as vulnerable. Yeah. And so, I'm finding lots of businesses and sectors that go, and yeah, my mitigation is in place. If I get attacked, I know how to recover. Tell me again why I need to change what I'm doing. And how do we get them to realize that, it's not the attack you've not had, it's the one you're about to have. And, it's that threat and that cost that's going to really struggle. I think I saw a number from, was it McKinsey recently, that it was around $10 trillion lost in IP and attack and maintenance out of the global GDP. Okay, 10 trillion. That's if we can halve that, that wouldn't be bad, would it? Yeah, that put a few pennies in everybody's pocket.
A few bob in my pocket for sure. Well, John, fascinating conversation. I feel we could continue to dig deeper. And maybe, I don't know, maybe after Info Security Europe, we can do that, have another chat.
Yeah, no problem.
I definitely am excited for your talk. Progress for the DSBD initiative, which is what we've been talking about here today, and the Cherry capability hardware, which is what you just referenced. That's on the keynote stage, Tuesday the 4th, 12:30, 12:30 their local time. And I'm excited to hear what you have to say.
Yeah, with pictures rather than just my hands
waving. Look at that!
Yeah.
not just hand waving, in Italian style.
Hopefully, we'll catch a few people on this, and I'll be around all day, so you can't miss me. A bright redhead, I've got a red shirt.
There you go.
Long red hair.
Red shirt.
Yeah, come and say, hey, John, I heard your talk. I would really like to know about this. and I'll say, yeah, and come and see me, and yeah, we'll change the world. That was the first thing I did when I started the program. I stood up in front of. It was a fairly small ecosystem at the time, about 20 people. We're here to change the world. And stand up now,
Nice.
we've got about 400 or 500 in the ecosystem. So yeah, let's
one chip at a time.
We'll make it everybody at some point with awareness. All right, son.
Right on. Well, John, it's been a pleasure chatting with you, and congratulations on getting this spot to raise awareness for this at the conference. And looking forward to the presentation and the conversations that come with it after. And you're very welcome back anytime. And for everybody listening, please do follow. We have lots of chats on the road to InfoSecurity Europe in London. Mark and I will be there on site to catch up with folks as well. Lots of stories, lots of cool stuff going, including what John's talking about Tuesday the 4th, 12:30 there. So John, thank you. Thanks everybody.
And thank you very much. Goodbye.